Okay, so bus travelling a straight line. Now for this one, I'm just going to end up displaying it because it's going to be too hard with my drawing tool to get there. But what we're doing is we're going from velocity up on the y-axis and time along the x-axis. We've got to start at 2.5 and then increase up to 7.5 using a straight line because it's accelerating uniformly. And then it's going to stay a straight line, a flat line, horizontal line for 20 seconds. And then it's going to have to, because it's going down uniformly, it's going to be a straight line again down for rest in 8 seconds. So you can see that you just should be labeling up the main points, and that's probably because it's going to be useful for part 2. Okay, that's probably why they got you to sketch the graph in the first place. So I'll just put my pen back on, and what we're now doing is calculating the average speed of the whole journey. Well, we know the time, so we know that speed is equal to distance over time, which means that we know the time because it's 40 seconds. We just need to work out the distance, and remember the distance is the area under. So if we talk about 1, 2, 3, we just need to work out the area of each. So 1 is a trapezium, and the trapezium is a half of the open bracket, the A plus the B, which is 7.5 plus 2.5 times by its height, which is 12 seconds. The area of 2 is just a rectangle, so it is 32 take away 12, which is 20 times by 7.5. 7.5, and finally we're going to have to add on our half of 8 times 7.5. So we'll just have to put that in our calculator. So we've got 7.5 plus 2.5, and then I'm going to half that, times it by 12, 20 times 7.5, add on 4 times 7.5, which gets us 240. So that gives us the distance is 240. So the speed is 240 divided by 40, which is equal to 6 meters per second is the average speed. Okay, the circle has this form, and we've done a few of this in the memory retrieval. So find the coordinates of the centre of the circle and the radius. So if I just try and rearrange the circle first, we get x squared minus 8x plus y squared plus 10y equals minus 16. And then I can complete the square. So we get x minus 4 all squared. That gets us x squared minus 4, but then we've obviously created an extra 16, so take away 16. Add open bracket y plus 5 all squared. That ends up creating an extra 25, so take away 25 equals minus 16. Add my 16 to both sides, so we end up with x minus 4 all squared plus y plus 5 all squared equals 25. I'll just move that 25 over. Let's just check what the question says. Find the coordinates of the centre. So the centre is going to be at 4 minus 5, and the radius is going to equal 5. Show that the circle touches the x-axis. So with a wee sketch of this, we've got 1, 2, 3, 4 minus 5 is the centre, 4 minus 5, and this perpendicular distance is 5. Now, unfortunately, this wouldn't be enough to get it, so you'd have to then just mention, well, about the y-axis. So y coordinate, it's quite hard for me to write, so I might just say it. So the y coordinate is minus 5, so the perpendicular distance, if the radius is 5, brings you up to the x-axis. Obviously the drawing can help, but you can't just draw the sketch and then just expect to get the mark, so you've got to explain it as well.